This video is going to teach you how to graph tangent functions and how to get the equation of a graph of a tangent function. So this graph that I've graphed right here is the parent function for the tangent function. So this would be y equals tan of x. And let's look at the unit circle to see why it looks like this. At negative pi over 2, so on the unit circle, tangent of theta equals the y values over the x values. And at negative pi over 2, the y value is -1 and the x value is 0. But if we put 0 at the denominator, the number is undefined. That's why we have an asymptote at x equals -1/2. I mean x equals negative pi over 2 and at x equals pi over 2, because you have the same thing the unit circle over here where the y value is 1 and the x value is 0. So if we do 1 over 0, that comes out as undefined. So there's asymptotes at every multiple of pi over 2 at the parent function of tangent of x. And for negative pi over 4 on the graph, these are the x and y values of negative pi over 4, and you can see they're actually the same number, but one of them is negative. So if you do negative square root of 2 over 2, let's like set negative square root of 2 over 2 to m, and square root of 2 over 2 is just negative m, which means this just becomes -1. That's why there's a point at y equals tangent of x at negative pi over 4, 1. And we have the same logic at x equals pi over 4, but these are actually the same value. So if you just put square root of 2 over 2 over square root of 2 over 2, you get 1, which is why there's a point at pi over 4, comma 1. And unlike the sine and cosine functions where the period is 2 pi, the period is where the graph repeats basically. So you like if you take one period and just repeat it, you get the original function. But here, the length of the period here is pi. So for the tangent function is special because the period is only pi, not 2 pi. Now let's talk about the transformations. So you already probably know about this formula. We've talked about it in our getting an equation from sine and cosine functions. If you haven't watched that, then I suggest watching it because it teaches the logic we're going to use in this video. So to find A, which is the amplitude, we can see how dilated these 1 and -1 is. So right now the space between them is 2, but let's say this were to be 2 and this -2. The space between them would be 4, which means the space has doubled, so A would be 2 in this circumstance. But if this was 4, this was -1, the amplitude's not 4. The amplitude is 2.5 because the space between them is 5, and 5 over 2 equals 2.5 because 2 times 2.5 equals 5. Pretty easy. And the B, this is the period. So as we've discussed in the past video, you probably think that the period uses 2 pi over b to get the period, and same with getting the period from a graph. But no, since the period is pi, you actually do a pi over b to get the period. So if b was, say, 3, then the period would just be pi over 3, which is pretty easy. And if you have a graph where this is like not pi over 2, but this is just pi, then this period, you can do the math, it would be negative pi over 2 to pi, which is 3 pi over 2. And you set 3 pi over 2 equals pi over b. And you can do the math, and it's going to become 3 pi b equals 2 pi. B equals 2 over 3. And that's how you get the period from the tangent function. Now let's talk about the h, which is the horizontal shift, this is pretty easy. You just look at the point where it crosses the x-axis and see like which point is. So right now it's at 0, 0. If it was at 0, comma pi over 2, then h would be pi over 2. And if it actually went this way, like if it crossed the x-axis at negative pi over 2, then h would be negative pi over 2, which means that it would be b times x plus pi over 2 instead of minus. And now let's talk about k. So k is actually pretty simple as well. There are multiple methods to find k, but the most reliable that I use is looking at the points that they give you. Usually, if you have a graph, they'll give you the points that have transformed from negative pi over 4 comma negative 1 and negative pi over 4 comma negative comma 1. So if this is 5 and this is negative 2, it's kind of hard to find out what k would be, but the difference between 5 and negative 2 is 7, which means that regularly this would be 3.5 and this would be negative 3.5, but it has been shifted up a bit. So we can do 5 minus 3.5 equals 1.5. So in this case, k would be 1.5. You can do this for anything. Just know that if these two values are the same but like negatives of each other, so let's say this is 5 and this is negative 5, then that means k is 0. But if they are different, that means there is a vertical shift and you have to do the method that I just explained. Now let's look at some practice problems. If you haven't watched our video on graphing sine and cosine functions, then I would suggest watching them. It's only 2 videos and it gives you the necessary knowledge you need to know before you start graphing tangent functions. If you think you can do this problem by yourself, then pause the video and go ahead and try it, but I'll just explain it right now. So first, let's look at what all these numbers mean. The 2, as we know, that means the amplitude is 2. So amplitude equals 2. This 1/2, we can find the period by using this 1/2 by doing pi over the number, which is 1/2, and it's 2 pi. That's just right, equals the period. And this minus pi over 2 means that there is a horizontal shift, and the fact that it is minus pi over 2 means that it is to the right. So there's a shift right by pi over 2. And this 1 plus 1 means that it's going up, means that the graph has a vertical shift up 1. These are all the transformations that this graph has. So now let's get to graphing it. So if you watched our video on how to graph sine and cosine functions, then you know that the first number we should look at is this number, the 1/2, or the number that's closest to the left of x. This number tells us the period, so let's draw our asymptotes first. And the fact that the period is 2 pi means that the asymptotes are going to be pi and negative pi. Now the next number we should look at is this, the shift right by pi over 2. Now what this number means is that the asymptote in the whole graph is moved to the right by pi over 2. So this will become negative pi over 2, and this will become 3 pi over 2. And now the graph isn't really to scale, but it's fine. We can redraw it later. And now the third number we should look at is this 2, which tells us the amplitude. Now normally we would have points at pi over 4, comma 1. But now since there's a period is 2 pi, this is going to become pi over 2. And since the amplitude is 2, this can be multiplied by 2, which means that this becomes 2. And same for this value, like this. And these are moved to the right by pi over 2, which means that this one becomes 0, and this one becomes pi. Pretty simple. And the last number we should look at is this number, telling us the graph has moved up 1. The only numbers that these affect are these two numbers, 2 and -2. So this one becomes 3, and this one becomes -1. Now let's redraw our graph so it looks a little bit better. First, we label our asymptotes, one at 3 pi over 2, and one at -pi over 2. Let's estimate around here. And now let's label our point at 0, -1, and our point at pi, 3. And now all we need to do now is just make a line connecting everything that we have. It's like this. And boom, your graph is done. Now, if this was a series graph, I would draw another period, label an asymptote right here, and just draw another one like this. But for the sake of this explanation, that's not really necessary. So now, this is your final graph. You're done. You've proved that you can graph this tangent function with all the transformations. Let's try another practice problem. If you think you can do this one by yourself, pause the video and try it, but I'll explain it right now. So first, let's write down the formula for our tangent function with transformations. Y equals a times tangent of b times x minus h plus k. So the order we find these numbers in is we find a and k first, which are the vertical transformations, and then we find b and h, which are the horizontal transformations. And we always start with the shifts, which means that we start with the k first and then h first. So we do k, then a, then h, then b. So let's find out what k is. We can see that we have a point at 0, 3, and on the original tangent function, on the parent function, the point is 0, 0, which means that the graph has been moved up by 3. So k is 3. Now let's find a. To find a, we need to start with finding what the points pi over 4, 1 and -pi over 4, -1 have been moved to. In this case, they've been moved here, which is pi over 8, 5, and here, which is -pi over 8, 1. And you can see this because they are exactly like 1/4 the distance from pi over 4 to -pi over 4, which is the period. And we need to figure out what the difference in the y values between these 2 points is, and then divide that by 2, because the original distance between the 2 y values is 2. So we do 5 minus 1 to find the difference, which is 4, and 4 divided by 2 is 2, which means that a is 2. And now the next value we need to find out is h, which is the shift. We can find the shift by looking at the asymptotes and see how much they've moved left or right by. In this case, since the asymptotes are -pi over 4 and pi over 4, since they are the exact same numbers but negatives of each other, there is no horizontal shift. But if this was a different number, say like -pi over 3, then there would be, because these are not the same number anymore. So this is just 0. The last number we need to find is b. To find b, we need to know the period. The period is -pi over 4 to pi over 4. In this area is pi over 2. And I've already said we can find b by setting the period equal to pi over b. And we notice that the numerators are the same, so the denominators must be the same, which makes b equal to 2. So this is just 2. Now let's just rewrite our equation, but plugging in the numbers. So it's going to be y equals 2 times tan of 2x plus 3. And this is your equation. And that's it. And yeah, that's really all you need to know how to graph tangent functions and how to get the equation of a tangent function from a graph of it. If you enjoyed this video or learned something from it, consider liking or subscribing. It helps us out a lot. And thank you for watching.